Welcome back. We're here with Jimmy, who's playing with pencil. And Jimmy, are you going to help us with our math today? No, I'm not going to mess with this pencil. Okay, so today we are going to be talking about rates and unit rates. And a rate it's a lot like a ratio, but you use it to describe two different quantities. And a unit rate is when you describe something like how much for one, like how much time does it take to do one thing, or how much does one thing cost, or how long does it take to go 1 unit of distance. You'll see what I mean when we start talking about it. Okay, we are on page 283. So let's start talking about this. So what is the cost of 10 bottles of fruit juice? Well, fruit juice buy 4 for $10. So there's our ratio, 4 to 10. So how can you use the tables or diagrams to make sense of the quantities in the problem? If we know that 4 bottles of juice cost $10, how can we figure out how much 1 bottle of juice costs? Or how much 20 bottles of juice costs? Let's see what Monica says. Well, Monica says if 4 bottles cost $10, then 2 bottles cost $5, and 8 bottles cost $20. Yep, so 10 bottles cost 5 plus 20. Is Monica correct? Explain. Well, let's take a look. 4 bottles cost 10, then 2 bottles cost 5. That makes sense. 8 bottles cost 20. That makes sense. So 10 bottles cost 5 plus 20. Yeah, she's right. So then 10 bottles would cost $25. Okay, so do you see the different equivalent ratios she found? She said 2 for 5 or 2 to 5. She said 8 to 20. And then she found out the cost of 10 bottles of fruit juice. What's the cost of 1 bottle of fruit juice? If 4 is 10 and 2 is 5, then 1 is $2.50. So the unit rate for fruit juice is $2.50, meaning 1 bottle costs $2.50. Okay, let's look at page 284. Okay, equivalent rates. Rates. So a rate is a special type of ratio that compares quantities with unlike units of measure. So, for example, 10 kilometers in 3 minutes. So if a race car continues to travel at the same rate, how long will it take to travel 25 kilometers? Well, let's look at how they solved it. They said they started off with that original ratio of 10 kilometers in 3 minutes. And then they filled in the table around it with equivalent ratios or rates. And they said, well, 5 kilometers would take 1.5 minutes, and 15 kilometers would take 4.5 minutes. 20 kilometers would take 6 minutes, and 25 kilometers would take 7.5 minutes. Another way is to write the rate as a fraction. Multiply both terms of the rate by the same number to find an equivalent rate. That's just exactly what we've been doing with ratios, right? And then also exactly what we did way back when we were working with fractions. So they've done that here. Think 10 times what equals 25? Well, 10 times 2.5 equals 25. So if you multiply 3 by 2.5, you get 7.5, and that way you find out that it will take a race car 7.5 minutes to travel 25 kilometers. Okay, Ready?
Try it.
At the same rate, how long would it take the car to travel 60 kilometers? It will take the car blank minutes to travel blank kilometers. Okay, what do you think? The same rate, how long would it take a car to travel 60 kilometers? What do we know up here again? Well, we know that it can travel 10 kilometers in 3 minutes. So we could multiply that 10 by 6 to get 60 kilometers. There's 60. And then we have to figure out, whoops, that's where the minutes go. This is where the kilometers go. So what did we do? We multiplied that 10 by 6. So let's multiply the 3 by 6 also. And then we will know that it takes the car 18 minutes to travel 60 kilometers. And we said 10 kilometers times 6 equals 60. 3 minutes times 6 equals 18 minutes. So Sal drew a number line to try and solve the problem. We used some double number lines earlier this year. Let's see what old Sal did. So he says it shows that at this rate, the race car will travel 35 kilometers in 10.5 minutes. Critique Sal's reasoning. Is he correct? Explain. Let's take a look at this double number line. So let's see, we started off 0 minutes, 0 kilometers. Then we said 10 to 3. We know that's our original ratio. 20 to 6 makes sense. 30 to 9 makes sense. So that means that 40 to 12 makes sense. And 35 should be right in between 9 and 12. So is he right? Yes, he is. Good job, Sal. Okay, let's look at page 285. Okay, Harvest Market sells a crate of Fuji apples for $12. What are 2 different unit rates that could represent this situation? Okay, well, Fuji apples $12 and it's 1 crate. Find the unit rate in pounds per dollar. So, we need to look at this picture. It tells us that this crate weighs 15 pounds. So pounds will be the unit we're using there. And so now we know that 15 pounds costs $12, and our ratio is 15 to 12. And what do we want? We want to find the unit rate. In other words, how many pounds of apples could you get for $1? So if you divide both terms by 15, you'll end up with 1 pound, and then whatever 12 divided by 15 is. So 15 divided by 12 is 1 1/4, or 1 25/100, and $1. So that means that for $1 you can get 1 1/4 pounds of apples. In this one, we find out how much 1 pound of apples would cost. So here our rate was per dollar. Here our rate is per pound. And because the dollar amount, or the pound amount, is 15, we're going to divide both terms by 15. When you divide 15 pounds by 15, you get 1 pound. When you divide 12 by 15, you get 8/10 or 80/100, or because we're talking about money, 80 cents. So the unit rate in dollars per pound is 80 cents per pound. Okay. Try it. A recipe for scrambled eggs uses 2 tablespoons of milk for every 3 eggs. What are 2 unit rates that could represent the ratio? So what do you think? Think about what we did up here. We did 2. We did 1 by the single dollar, the $1, and then we did another one that was by 1 pound. So what have we got here? We've got tablespoons of milk and eggs. So what we'll want to find out is how many eggs would you use with 1 tablespoon of milk? Or how much milk would you use with 1 egg? So let's see, the ratio here you could say is 2 to 3. So if you divide first both by 2, you will get 1 tablespoon of milk for 3 divided by 2 is 1.5. 1.5 eggs. So 1 tablespoon of milk to 1.5 eggs. Or if you wanted to know how much milk to use for 1 egg, then you would divide both sides by 3 because there were 3 eggs. And then you'd get 1 egg and 2/3 of a tablespoon of milk. Okay? All right. Now, example 3. Use unit rates to solve problems. Okay? Math problems. Unit rates won't really help you with like personal problems. Anyway, a unit rate is a rate in which the comparison is to 1 unit. Like we did 1 tablespoon or 1 egg or $1 or 1 pound. So let's look at this problem. How far could the family travel in 8 hours if they maintain the same rate of speed? Okay, here's their rate of speed, 25 miles in 5 hours. Okay, if they maintain that speed the whole time they're riding, we could look at it a couple of different ways. We could say, how long does it take them to travel are they doing kilometers or miles? How long does it take them to do 1 mile? Or how far can they go in 1 hour? Let's look at this double number line here. We've got miles and hours. And here they've got the 25 miles in 5 hours. We want to know 8 hours. So we keep counting up 6, 7, 8. And then how are we going to count up here? 30, 35, 40. So in 8 hours, they could go 40 miles. Let's see what we did here, though. They said, find the unit rate in miles per hour. In other words, how many miles can they travel in 1 hour? So because it's 5 hours and we want to get down to 1 hour, we're going to divide by 5. And when you do that, you end up with 5 miles in 1 hour. So the unit rate is 5 to 1 or 5 miles per hour. This is a different way to do it. This time, this is a different question actually. So this is another way to answer that. How far could they travel in 8 hours? So if we know the unit rate is 5, and we want to know how long they could go in 8 hours, then you're just going to multiply both terms by 8. And then you get 40 miles in 8 hours. The family could travel 40 miles in 8 hours. Okay. Try it. Canoeing club never gets old. A canoeing club travels 78 miles in 3 days. How far could they travel in 5 days if they maintain the same rate of speed? Okay, I want you to do that on your own. Pause the video here and then come back and check your answer. All right. Canoeing club. 130 miles. 78 miles in 3 days. So there's your original ratio. And I want to know how far could they go in 5 days? Well, if I figure out how far they can go in one day, and then multiply that by 5, I get my answer of 130 miles. Okay? Good. Let's take a look. I think we have one more page today. Okay, page 286. A rate compares quantities with unlike units of measure. By unlike units, what do we mean? This is dollars and cents. This is oranges. Different units. A unit rate compares a quantity to 1 unit of another quantity. So again, we're getting down to the 1 unit. In this case, they're showing 1 orange. 50 cents for 1 orange. Okay? All right. Do you understand? What are rates and unit rates? Explain. Be precise. Use what you know about ratios to describe a rate. Okay? Reasoning. A bathroom shower streams 5 gallons of water in 2 minutes. 5 gallons in 2 minutes. Find the unit rate for gallons per minute and describe it in words. Do you see how it says per minute? So that tells you it wants the unit rate for 1 minute. So if it can stream 5 gallons in 2 minutes, how much can it stream in 1 minute? Now, find the unit rate for minutes per gallon and describe it in words. So this is minutes per gallon. So that means it wants to know how many minutes will it take for 1 gallon. In this one, the unit rate is per minute, and in this one, it's per gallon. So I'd like you to do all 3 of those problems. Pause the video here and come back when you're ready to check your answers. Okay. I don't know about you, but I'm really sick of answering this question. And it says it right there. So if you wrote about how a rate compares quantities with unlike units of measure, and a unit rate compares a quantity to 1 unit of another quantity, you are right. All right. When you go to middle school, don't ever write as one of your answers. Teachers don't like that. Okay. Be precise. Okay, so what do you know about ratios to describe a rate? Rate is a ratio. Rate is a ratio used to compare a number with different numbers with different units. Okay? Now for the shower question. 2.5 gallons per minute, 2/5 of a gallon per, 2.5, water and 2 gallons per minute, 2.5 gallons per minute, 2/5 of a gallon per minute. All right. Next section. In 4 and 5, find the value of n. Hey, we haven't done that in a while. So that it's miles and hours. If it's 45 miles in 4 hours, how many hours for 135 miles? Solve that one. And now, number 5, pounds and cost. We don't know what it's pounds of. It doesn't tell us. You can just imagine your own thing. How about pounds of cats? Okay, so what we see here is that 1 pound of cats costs $2. How many pounds of cats can you get for $5? Think about that one. Jenny packaged 108 eggs in 9 cartons. Write this statement as a rate. So you could do it, you're looking at cartons here. There's 9 of them. How many eggs in 1 carton? Okay. Anna Maria read 40 pages in 60 minutes. What is her unit rate in pages per minute? Pages per minute. So how many pages does she read in 1 minute? Okay. In 8 and 9, use the unit rates that you found in exercise 3. So exercise 3 is right back here. It's the one about that family and their bicycle ride. So we're using those unit rates. What? How many? Exercise 3. It's talking about showers. Oh, that's example 3. Exercise 3, it's right here. So we're talking about the shower. Okay, so how many gallons of water does the shower stream in 6 minutes? We found out how much it streamed in 1 minute. How much in 6 minutes? And then, how long can someone shower to use only 10 gallons of water? Okay. Work on those and unpause the video when you're ready to check your answers. Okay. So for this one, n equals 12. And for this one, how many pounds of cats can you get for $5? The answer is 2.5 pounds of cats. That's not a lot of cat. Okay, so Jenny packaged her 108 eggs in 9 cartons. So I wrote it like this: 108 eggs, 9 cartons. Write this statement as a rate. So then how much in 1 carton? Well, let's divide 108 by 9, and we get 1 with 1 left over. Bring down the height, 12. So, boys and girls, I bet you didn't realize this, but there are 12 eggs in 1 carton. Okay, so how about Anna Maria? 40 pages in 60 minutes. That means she reads 2/3 of a page per minute. All right. How many gallons of water does the shower stream in 6 minutes? 15 gallons. And finally, how long can someone shower to use only 10 gallons of water? You can shower for 4 minutes to use 10 gallons of water. Okay. We are done for today. Good work. Keep plowing away, and I will see you soon. Bye.